Now I will demonstrate scenario 2. Demonstrate how your tool shows power usage changing over time at the device, rack, row, and room level. Show how changes in capture frequency can affect reporting and decision making. Raritan DCIM solution has a highly user configurable dashboard that allows you to take massive amount of data and turn it into information and make real-time adjustments to get better information to help answer the questions you have. So I'm just starting off here with the standard dashboard that I have that maybe management is looking at to monitor PUE by data center. So I have 3 gauges. I can trend PUE over time and then have real-time events coming in at my dashboard, such as a warning about under voltage or critical over humidity condition or active power over a certain level or an airflow sensor unavailable. And I just want to point out that this dashboard is highly user configurable with drag and drop technology. You have a list of available widgets such as a floor map, PUE gauge, cooling chart, trend chart, bar chart, forecast chart, and you can easily make changes by dragging and dropping and sliding around different widgets and save, and there's no program required, and now I have an updated dashboard. So I can create as many dashboard reports as I want, and I could share dashboard reports. Very specifically, I have across the top some of the scenarios that were laid out in this. So with one click, I have a view of my load over time for room NY1 in my New York data center. And I can export this data, but more importantly, I can easily, without going to a different page, without programming, adjust the configuration. So I'm looking at active power right now, but I could also be looking at amps, kilowatt hour, carbon footprint, energy cost, total energy including cooling, total energy cost including cooling, inlet temperature, outside air, inlet humidity, outside air, airflow, and air pressure. And so let's just say, for example, I want to adjust this and look at something like cost, right? Because I'm looking at power and I want to look at energy cost. I have the ability to adjust that. I could also look at any different time frame. So let's say I want to look at, instead of this, I want to look at last month or the calendar month. I can adjust the granulator frequency. I could adjust with nice visualization of what I want to chart, and I say save. And so now I've just adjusted this chart to see what's my energy cost for this room for the month of May. And I could look at any given point, so any given day in that month, and look that on this particular day, May 10th, it costs $626 in energy for that day. I also have here a second widget, which is our capacity forecast widget. And so this room has a capacity of 8 kilowatts, denoted by this red line, and I'm observing my measured data over a period of time, and the system's performing a root mean squared calculation to project my available days of capacity at that trend. So I have 178 days of capacity remaining at that trend. But as we all know, it's very important to be able to manipulate the data. So in this particular case, again, highly user configurable, I'm looking at past month's data. But maybe I'm concerned that the past month is not as indicative of my future performance as maybe the past 3 months. So I can easily adjust this widget. And now if I look at a longer trend period of time, 3 months, I see that I have much more remaining capacity, 95 months. Next, if I want to look and drill down from the room to the row, I could drill down and I'm looking at the row. I can have one row or many rows charted on this chart. I also have the ability to look at things like a cooling chart for this row. And so here, Raritan has a patent for this cooling chart. We define, we display the ASHRAE range, American Society of Heating, Refrigeration, and Air Conditioning Engineers, on a psychometric chart and make it very easy for customers to understand what their situation is with sensors. So in this particular case, I have sensors that are too hot, so 82 degrees gives the location. So these two sensors are too hot according to ASHRAE. and these sensors are too dry, which might cause static electrical discharge. And again, I can export this data to go and investigate that. I can also manipulate this and make configuration changes. I can also have an overview health of my environment, and I can click down if I have a critical event here. I can click and drill down to look at that particular event. Next, I want to look at rack loads. So I'm looking at all the racks in row 1, and so I have a trend line, and so rack 1B between 9 and 10 p.m. has a load of 1.236 kilowatts. I also can have an at-a-glance view of my legend of my maximum kilowatts over this period of time. I also have the ability to see gauges. So I have a gauge for each rack where I know the actual load right now, the maximum load over a period that I specified, and the minimum load over a period I specified. So I could, from the settings, change that period, and instead of saying past month, I could say past 24 hours if I want to see what's the load, and I see there's a slight narrowing of the variation. And so, again, the dashboard is highly user configurable to help you answer the questions you want. Next, I'm going to drill down to IT device and applications. In this particular case, I'm leveraging the configuration that makes it easy to draw a chart such as this. I'm selecting active power, charting hourly, and I'm selecting rack 1B, but I'm going to display one line per child. So all the devices in rack 1B are displayed. And so each line is a cabinet. I can mouse over and see the load at any point in time. So this load, that load, I could see my maximum loads for these IT devices. So over this period of time, Windows XP.122 has a maximum load of 107 watts. I also have the ability to chart applications, so I can look at each application that I'm charting and understand, for example, what's the maximum load of my help desk or my load over time for my help desk. And so that's a high-level overview of the ability to take data and turn it into information. And finally, what I want to show you is the Raritan DCIM solution, highly differentiated ability to collect massive amount of data at very fine-grained samples, while at the same time being network-friendly and resilient. The vast majority of management systems perform what's called standard polling. In this particular case, they poll every 5 minutes and take the latest reading. The Raritan DCIM solution can do that and can support not only Raritan PDUs, but any third-party PDU, CRAC, UPS, rack PDU. But in addition to that, you have the ability to set the polling interval at different range. So let's say I set my polling interval to be 10 minutes, but I want to enable buffer data retrieval, which is a unique capability. And let's say I want to select a 1-minute sample. What this will do is send a command to the intelligent PDUs to create 1-minute samples. And the Raritan intelligent PDUs have stored memory on them such that they could store 120 samples. So if the sample is 1 minute, you could store 2 hours worth of samples. And what it does is internal sampling at a 1-second interval. Each one of those 1-minute samples has an internal sampling rate from the PDU at 1 second. And therefore then it creates a max, min, and average for that 1-minute interval based upon a 1-second sampling, making it more likely that you're going to catch maximums and minimums. In addition to that, the Raritan intelligent PDUs have an energy chip that is billable grade energy level such that it provides information with less than plus or minus 1% error. So that's not even sampled, that's just collecting those readings like a meter reading. This configuration is network friendly and resilient because the solution will only go out every 10 minutes to collect these 10 1-minute samples, but also if the network is down for an hour, no worry. The next time the solution connects to the device, it'll pull all of the readings from memory. And in this particular configuration with 1-minute samples, it has the ability to store 2 hours worth of readings. If I want longer storage, I can increase the sample rate, and if I made the sample rate 10 minutes, it could store 20 hours worth of data.